Hey, I'm Ben Bowlin, and today's question is, how much does planet Earth actually weigh? Well, it'd be more proper to ask, what is the mass of planet Earth? And the quick answer to this question is, it's approximately, are you ready? 6 times 10 to the 24th kilograms. In layman's terms, that's a lot of weight. It's heavy. Just in case you're wondering, this is a reproduction. It's not to scale. I am not that strong. So there's another interesting sub-question here, and that's, how did anybody figure this out? It's not like the planet Earth can just drop on a scale each morning before it takes a shower. It turns out that you can calculate the mass of something if you know the magnitude of its gravitational pull. And that's because any two masses have a gravitational attraction for one another. So if you put two bowling balls near each other, they're going to attract each other gravitationally. This attraction is extremely slight. I mean, it's not going to destroy the planet to put your bowling balls too close together, but if your instruments are sensitive enough, you can measure that gravitational attraction that these two bowling balls have. And from that measurement, you could determine the mass of the two objects. The same is true for two golf balls, for instance, but in this case, the attraction is even smaller because the amount of gravitational force depends on the mass of the objects. Newton, a small-time physicist you might have heard of once or twice, showed that spherical objects make it possible for us to create a simplifying assumption that all of the object's mass is concentrated at the center of the sphere. He then came up with an equation that expresses the gravitational attraction that two spherical objects have on one another. Its force equals the gravitational constant times the mass of the first object, wait for it, times the mass of the second object, wait for it, over the distance between the two objects, squared. Assume that Earth is one of these masses, okay? And that a 1 kilogram sphere is the other. So the force between them is 9.8 kilogram meters per second, squared. We can calculate this force by dropping the 1 kilogram sphere and measuring the acceleration that the Earth's gravitational field applies to it, which is 9.8 meters per second squared. The radius of the Earth is 6,400,000 meters. So if you plug all these values in, I'll wait. Great job. And solve for M1, you find that the mass of the Earth is 6 times 10 to the 24th kilogram. So that's how much the Earth weighs, or more properly, the mass. Thank you so much for watching. Do you have any other questions, anecdotes, suggestions for upcoming episodes? I'd love to hear from you. Please leave a comment down here and our YouTube page, and we will see you next time.